Hi there. I just recorded a video and I'm even uploading it, but I think I'm going to delete it. I'd like to try and explain what I want to do. Try to do a better job of explaining anyway what I'd like to do with this aggregation. It's something I must. I might have realized, I suppose, immediately, if only I'd realized the following fact. Now what's this down here? Going. All of these are just regular old. Okay, no, this is my server. Let's kill it. See this video here? I don't have this project anymore. I must have deleted it or something. But if from a long time ago, this would have been lesson 84, I explained the concept of marshaled calls in the context of multiple threads. So that is, if you wanted to make a function call and have the call not have the actual function call occur in a different thread, and have that call be a blocking call, if the function doesn't return until the call is complete, then the method that people employ to do that sort of thing is called marshalling. Marshalling is like the word sounds. The calls are queued, put in some kind of queue, okay, that calls to be made, and dequeued and called, and somehow or other a signal is sent to the caller when on completion of that function call. Now this RPC server thing is an example of a marshaled. The calls are examples of marshaled function calls. I'll show you that right now. In fact, it's quite easy to show. Here's my, okay, not this yet. Here's my server. And on the server is this hello proc, okay, which previously was just doing printf. Now I want to do something, I want to change it slightly to print out some information, like in this example, where the printing displayed what the current thread ID was. Okay, so that's one thing I'm printing out. This here is just a backspace to get rid of the spinner's thing, the spinner character. Function name, thread ID, the string passed in, and then what I'm doing here is to make things happen slowly, I'm setting a timer, a timeout thing. Giving it a random range between 30 seconds and 1 minute. Maybe I could go from 10. But I don't want it to terminate so quickly that I don't have a chance to make another call from another process, not another thread, but another process, and show you that the server will be servicing, I suppose is the right word, servicing both those calls, but in different threads locally. Okay, now I can run the server under the debugger. I don't have to. I can. just by doing F5. So that's the server running. Now, what I need is a bunch of these command boxes. Make 3. I need 3. I want them small. Okay. So we're all ready to call the client. Now, the first thing that will be, I'll just call one of them. First thing that will be printed out is that the process has begun, right? And then we're assuming that it's a longish kind of process, and then eventually it will complete. And what you're going to see is that the call is blocking. It's a Marshall call, just like in the Marshall example. This, I'll use this one. The function will not return until the server has completed the request. See, the server is working on the request, but this program hasn't terminated. It's blocked, waiting for that request to complete. I'll just let it complete, and you'll see that once it does finish that task, this will be released. And so therefore, this client here, when it makes calls to the server, it's as if it's calling its own local function in a single thread, that, and the calls would happen in order. Okay. Now it's no coincidence that the thread IDs are the same. Now I'm going to do that. Make it exactly the same string, just for fun. And well, okay, I'll make them different for the first test. Do this and this. Now the server is now processing both requests at the same time, but in different threads. Okay. I'll put a breakpoint on the next go through this, and I'll show you that there are 2 threads, both in the same function, both on this wait line. Oh, it's this one, okay. Oh, they both completed. You'll note that goodbye world matches up thread ID wise with the string passed in. A thread is like a separate process in a way. If I put a breakpoint here, well, first let me get one going. Put a breakpoint here. And get another one going. Okay. Now, hello proc is being executed in 2 different threads. Each of the threads where it's being executed corresponds to a different process, right? Well, this one actually, well, just showing that it's on the wait call. And this one, I just put the breakpoint here, but if I put it here and then break into the program. They would both be on that wait. Now they're both, well, the first one's going to complete right away now because the time will elapse. So I run this, but the second one is should still be. Why is this? That's wait. It should have finished. Hello world 90. It is finished, but maybe it hasn't gotten a signal back telling it that the one calling. Whoops, it's hard to do. Has processed the message, whatever signal or whatever, that tells this thing that everything's fine back home here. All right. Well, that's one thing. It's very much like marshalling. Sorry, it is marshalling. These calls are marshaled for a given process. This thing this box is not able to make two calls in a row because it's blocked on each call. But another process can come in and use the same function, and it too gets blocked. One of the things I realized from reading, I found out through reading the help, is that you can set the minimum and maximum number of basically concurrent calls, which means the number of threads that the server will service simultaneously. Now the default here is a great big number, but I changed it to 2 just to see what would happen. Okay, so what I'm going to do is try to make 3 calls and see what happens on the third. So I'll do this. Now if I try to do one here, I get an error. Immediately it returns with the server is too busy to complete the operation. Okay, so it didn't allow that call, which makes sense. That's what I told it to do. I told it 2 is the maximum. If one of these would quit, it's hard to tell. It's these 2 currently going. Then I will be able to. I can get ready, and as soon as one of those completes, I was able to get in there with my string. Okay. Now, one of the weird things that I didn't expect when both of these are done is that the shutdown is not synchronous. It's not a blocking call. Let me get another request going. And if I just do this, it can't process the shutdown, even though that's a different function. But once one of these completes, you'll see that the shutdown order completes immediately. However, this thing doesn't shut down right away. It waits to complete its request. Okay, one of them completed. Try to shut it down, and it hasn't shut down. What it's doing is it's still stuck on that wait, right? And it can't interrupt it. Presumably it can't. So it has to wait for that procedure to complete. When it finds out that there was a shutdown request, then it's shut down. Okay. Now, that's one thing. The other thing is this HTTP client thing and aggregation. And what would be a thing that one might want to do in order to combine RPC and HTTP in some manner. The thing like I said, I should have realized right away is that this is a perfect example of something where we would like to create an object that exposes this interface, okay, the HTTP interface, but where the calls are issued remotely. See what I mean? Like, I would like to do a remote get page, right, on another machine, sort of like imagine like a proxy. To proxy the HTTP requests by issuing the calls on another machine that might not be behind a particular firewall, let's say, at your work, where you want to watch videos, but the boss won't let you. So the idea would be to create one of these, not this object, but a different kind of object, which has within it has and creates an HTTP client, let's say as a member, right? So the server, this guy, perhaps either in the thread proc or in this proc, well, the calls are received in here, right? I suppose you could, in here, one could make a different procedure for each of those HTTP requests, let's say, and then uses its own internal HTTP client to make the request and somehow return the data back to the caller. This thing doesn't return any data, neither does this shutdown. But that's one of the things that is possible, right? In the header or in the interface language, you can put the keyword out here, right? So the get, maybe it just exposes an interface exactly like this, okay, minus this part. Connect to a server and so on. I would use the object just as if it were an HTTP client locally on my machine. However, the calls would be redirected through RPC to another server, and this get here would be invoked through RPC using an out parameter type thing. Now that data would be allocated locally. On the client side, the client having these allocation functions would be set up to receive the data and store it in some kind of buffer, right, which would be passed back to me, and freeing the buffer would invoke this call, right? So it would be an example of the use of these allocate and free, but also this would be something that demonstrates how a proxy server works through aggregation. We already have this interface, right? And if it's not working, the idea is that it doesn't work on my machine because of some firewall issue, and I would like to use RPC to issue the calls from a different machine in the office, possibly, or it could be, some other way, like a proxy server on the internet. But the use of the object should be through this same interface. So it's a perfect example for aggregation, where the functionality is exposed as another implementation of this interface. If that's true, then any program, any software I happened to have that used this interface would not notice any difference. Like Internet Explorer would work as it normally does in opening web pages and downloading and uploading and all that, provided this interface is faithfully mimicked. That's my plan. Next thing I want to do. Now, is there something else I wanted to say? I showed you that there were various threads, that it's blocking, that it's another example of marshalling, which you can learn about by going to lesson 84 on my page. It's a very simple concept, and it comes up everywhere. It's a very important concept. And RPC, as you just saw, these remote procedure calls are marshaled calls. They're blocking calls, so that when you make a remote procedure call, it's just as if you're making a local call, in that the function doesn't return until the operation is complete, or if an error occurred, right? The error is actually occurring on the remote side, not on your local machine, but you wouldn't know the difference. Whatever error that occurs remotely is turned into an exception that is thrown, just as though an exception occurred locally. Even though no exception did occur locally, it appears to your program as though things are just happening locally. Anyway, that's my idea. Hopefully it'll work out. See you.